Okay, the first math question we have here, the sum of two numbers is 16 and their product is 55. What are the two numbers?
Yeah, I can take that one. That is a system of equations problem. So what you notice here, and I'm going to write out some of this, we're saying that the sum of two numbers, and the reason why I'm writing this out is because I find that oftentimes, especially I'm teaching this in advanced algebra right now as kind of a review for algebra. One second. And I find that sometimes, like, the hardest part about these problems is actually figuring out what it's asking and how to set up proper equations. So I'm going to say find the two numbers. So I'm going to kind of walk through how we would think about this. Because again, I think that's the most challenging part. If you're doing a problem like this, I'm assuming you've already solved some systems of equations using some like elimination and substitution, different methods like that. So I'm assuming that you're just kind of struggling with writing things algebraically in this case. So one of the things that we always talk about here is if you're trying to solve any kind of equation or any kind of word problem, application problem, the best thing to start with is always to think about what are you looking for, like what are the variables you don't know what they are or that you're looking for, and how can you set those up. I'm going to go ahead and say that I have two numbers that I don't know. Well, let's take a step back. One thing that students often try to do is just guess on a bunch of these, and they say, okay, the two numbers that add up to 16 are 8 and 8. Do those multiply? I forgot to write product in here. Do those multiply to give me 55? Well, 8 times 8, let's see, the product is 8 times 8 is 64, so that doesn't work. And you can keep on guessing and checking all these different things, and you might find one of two things, that the numbers might not be whole numbers, in which case you have to guess all these crazy decimals. You might also find that sometimes the numbers we work with are bigger, and it might just take a very, very long time. So we like to do this algebraically. And we're going to think, I'm going to just set up, we want to know two numbers, so I'm going to set up two variables. And I'm going to call x my first number, and y is my second number. And again, if you just set these up, sometimes just the act of writing down that x is representing a number and y is representing a number is going to help you set up these equations. So if I look at this first part, the sum of two numbers is 16. So that in itself, I just think add up two numbers and they should add up to 16. I think that's fairly straightforward, but we need to include these variables that we identified. So if x is a number and y is a number, the sum of the two numbers would just be x plus y. And we're saying added up equals 16. Often when we have these problems, this word is, you could think of as equals, and sum we should be thinking of as plus. So if I just have this piece of the equation, I would automatically think I don't have enough information to figure out what either one of the numbers is individually, because I have two variables. In order to solve for either of them, I have to have two equations. So this second part is saying, and their product is up here because I forgot to write it, is 55. So when we think of product, you should be thinking up here, multiplication. So I'm going to put a dot because I'm using x for multiplication. I'm using that times symbol. Now, same idea. If x plus y is 16, that's the sum. Product is going to be x times y is 55. So now I have two equations and I have two variables, so I can solve this. So one thing that we're going to do is called the substitution method. If you have learned elimination method, it's not going to work in this case because in one case we're doing sum, the other one we're doing product, so we don't have equivalent operations there. And really, in order to do elimination, you need two kind of addition type problems. So when we do substitution, what we're really trying to do is solve for one of these variables in terms of the other. I'm going to pick this one because I think it's a little bit easier to work with. So x plus y equals 16. I'm going to pick one of these, and I don't really care which one it is, but I'm going to solve for x. So in order to solve for x here, I need to get x by itself. So I'm going to subtract y from both sides, and I'm going to get x equals 16 minus y. All right, so with this now, I've solved for x in terms of y. And again, we said one of our problems with these equations is I have two variables. So now what I can do with this is I can say, look, I know x equals 16 minus y, which means I can replace this value of x right here. So I'm going to take this 16 minus y over here, and I'm going to plug it in. So I got 16 minus y times y equals 55. And so if you look at this, all I did is I solved for y, and I said, OK, I know x is equal to something else, so I can plug that in. That's my substitution. Now I've got an equation right here that I'm going to highlight in yellow. This is an equation we can solve because I have one variable in one equation. So I'm going to get 16y minus y squared equals 55. And now I'm going to go through this a little bit quicker in solving for y, just because I don't want to talk for 15 minutes about this one problem. But also, I'm assuming that if you're at this point, you're comfortable solving quadratic equations. And you should know this is quadratic because our biggest exponent is squared. So I'm going to rewrite this. If you remember, solving quadratics, oftentimes we need to set one side equal to 0. So in this case, because my y is negative, I'm going to move the y over to the other side. So I'm going to add y squared, and I'm also going to do this in the same step. Subtract 16y from each side. You're going to notice these are going to cancel out. So I'm left with 0. So 0 equals y squared minus 16y plus 55. All right. So now we have a few options in terms of how to solve this.
We could factor it.
We could factor it, do
and
zero
in that
product
case, guess
property.
what we would be doing? I just find it's funny.
What's that?
If we factor it, we're finding something whose product is 15 and adds to give us negative 16.
Oh, that is actually pretty funny.
Sorry, it's
kind of a nerdy math joke.
But
yeah, actually we are factoring this. So when we factor, which is funny because the problem is saying two numbers that add up to something and multiply to get something else, we're doing kind of exactly that thing, which I said let's not do that at the beginning because we have to guess and check a lot. But now with factoring, we're going to guess and check. So yeah, that is actually pretty funny. OK, so we're going to factor this. And again, I'm assuming that you're comfortable with this. If you are not sure what we're doing here, and this was your question, I would look up solving by factoring or solving quadratics by factoring. But like Becca said, what we're doing is finding the factors of 55 that are going to add up to negative 16. In this case, so I'm going to have a y here, a y here. It's going to be negative 11 and negative 5. Right? Negative 5 times negative 11 gives us that positive 55. And then adding them together, I get the negative 16. So using zero product property, we could set each of these equal to 0. Y minus 5 equals 0. Y minus 11 equals 0. And I get y equals 5 or y equals 11. You will find this is kind of an interesting problem because right now we're saying there's two possible solutions for y. This happens a lot when we're doing kind of some more advanced algebra stuff where we have two possible solutions, but one we can eliminate because it's negative and we can't have a negative number. In this case, the reason why we get two possible numbers is because we don't really have to distinguish which one is x and which one is y. I solved this one for y, but if we look at my original equation, it's not saying y is the first number or the second number. It's not saying y is bigger. There's no constraints there. So I could have just as easily made this y plus x and this y times x, and we could have flipped everything around, which means if you actually think about it, this could either be the first number or the second number. So our numbers are 5 and 11. So actually, what Becca said is we eventually got to a point where we had to do this guess and check. We could have done the guess and check to start with, and we probably would have saved, well, you can look at your clock and see how much time we would have saved. But the point I was making earlier is like that method is not always going to work for every problem. So this is the very long way to do a problem that I did guess and
Ended
check
up having
for.
a super obvious answer.
Yeah. So we could check our answers by now saying, okay, do these two numbers add up to 16? Yes. Is their product 55? Yes. That is our very long answer.
Well, it is kind of nice to, I mean, it is kind of nice to know that if the numbers were not
Yeah.
whole numbers, because that would not be fun to guess and check, right? You know.
In which case, in the end, we would have had to do a quadratic instead of this guess and checks. Like I said, sometimes we get a lot worse numbers to work with. In which case, you know, if my numbers are much bigger or my quadratic's much more complicated,
Right.
then I'm still not going to be able to guess and check and get the proper factoring, or it might not be
Yes.
factorable. In which case, you'd have to do
Use
quadratic
formula, right?
And in a high-stakes test like an ACT or an SAT, they're probably hoping to push you to that point, right?
Yeah, they
When
probably
they
don't
want you to
want
be
you
using
Yes,
a
most
quadratic.
likely.
Yeah.
Yes, that's
So
very
guess
true.
and check's not really going to work in those circumstances.
No,
yeah.
but also a valid problem-solving method
Yeah.
if you know if the problem is simple enough for that. So multiple methods, I guess.